Hey, hello everyone. So before going with the next video, I just thought that let's just cover bit prerequisites which you will need to learn any of the bit manipulation topic, whether it be bit manipulation with sliding window or bit manipulation with prefix sum, subarray sum, which we are doing. So for all these things, you actually need some 4 5 things to understand related to bits. So I'll just cover those 4 5 things which are needed. Okay, I'll not go in deep of bits. Okay, I'll just go on top level of it, which is useful in all those cases, which will be useful in all the bit manipulation or bit masks related problems. Fine. So first thing to note is every number is represented in 32 bits. Okay, 0 to 31 index, I can say. Okay, because maximum integer is 1e9, so it will be represented by 31 32 bits at max. 32 bits at max. Okay, fine. We have 4 or 5 different things and represented by this symbol or represented by this symbol. XOR represented by caret symbol. Okay, left shift. Okay, left shift represented by this will multiply, or we can say it will have if I do any ith bit left shift 1. Okay, this means my bit is shifted left by I times. That means only ith bit is 1 and rest all are 0. Or simply I can say whatever left shift I do, 1 left shift I, this means i'm multiplying I'm multiplying these two things. I'm multiplying ith bit with 1. Okay, and same opposite for right shift. Right shift actually defines division. So if I have 8 right shift to 2, this gives me 4. Okay, but right shift is mostly not used in many of our cases. We'll be mostly using left shift over here. Okay, uh, just to have you a little bit more idea. Okay, let's say you have this number 7 whose bit representation is 111. So actually this is all zeros and then 111. Okay, this is how the bit is represented. Okay, and starting from this, this is 2 raised to 0, this is 2 raised to 1, and this is 2 raised to 2. This will be 2 raised to 0, this will be 2 raised to 1, this will be 2 raised to 2. Okay, so actually it's 2 raised to 2 plus 2 raised to 1 plus 2 raised to 0, which is nothing but 4 plus 2 plus 1, which is 7. So this is the bit representation of 7. And basically the bits assigning start from 0th index, but 0th index in string will be represented in this form. Okay, and the rightmost or the left, I can say the leftmost bit will be 31st and the rightmost will be 0, starting from the 0. Okay, fine. So our first topic will be to check each bit. Okay, so let's say we have some num. Okay, int num, and I'll be going from 31st until 0. So what we can do, your bit will be what? Num and 1 left shift I. This will be your bit, either 0 or 1. So basically not 0 or 1, it will tell you whether the bit is 0 or 1, whether the bit will be 0 or 1. So I'll cover in this only to check if ith bit is set. What you can do, you can just check if num and 1 left shift I. Okay, if this is something which is not equal to 0, this means your bit is 1. This means your bit is 1, else your bit is 0. Else your bit is 0. If num and 1 left shift I, okay, if it is not equal to 0, this means the bit is 1. And if it is equal to 0, this means bit is 0. So what we are doing, the num is actually 7. So it's 111. And let's say I'll be checking for 0, 1, and 2. Let's say for second bit. So 1 left shift 2, 1 left shift 2 will be what? Just second index will be 1, and 0th and first index will be 0, second index will be 1, rest all will be 0. So if you'll do ending of this 2, mm, ending of 111 and 100. Okay, I'm writing in short, I'm just ignoring all rest digits which are just 0. This will be 100. Okay, so it's actually not 1 or 0. You will get some number. Num and 1 left shift I will give you some number which is actually not 0, some number greater than 0. This means that your bit is 1. But let's say I want to check the third bit. Okay, here the third bit is 0. Okay, third bit is 0, and I'm doing its end with 1 left shift 3. So 1 left shift 3 will be what? This thing, and rest all zeros in ahead of 1. So if I'll do ending of this to 111 or 011 and 100, I'll do end of this to, then of course I'll get what? 0000. This means that the third bit is 0. So I hope you got how to check if the ith bit is set or not. Num and 1 left shift I. Okay. Now third thing. Third thing is to make ith bit set. Okay. Now we have to make ith bit as set. So what we will do? We'll do just num is equal to num or 1 left shift I. This will set the ith bit. Let's say I want to set third bit in 7. So I'll do 1, 1, 1, or 1 left shift 3 will be what? We have just now see 1 left shift 3 is 1, 0, 0, 0. If I'll do ORing of this 2, then what will I get? 1, 1, 1, 1. Okay, so this will set ith bit in your num. In your num. Okay. Now I have to clear ith bit from num. Means I have to make it 0. Then what will I do? I'll do num is equal to num, and just remember, whenever you need to set something in the num, you have to do or. And whenever you have to clear something, you have to do end. Okay. Negation of 1 left shift I. What you have to do is negation of 1 left shift I. So let's say I want to clear the second bit. Second bit is this. I have to clear the second bit from 7. What will I do? So this is actually 7. Okay. I'll end it with negation of 1 left shift I. So 1 left shift 2 will be this thing. I'll do its negation. I'll do its negation. So negation will be just bits swapped. So this will be what? 0, 1, 1. So just ith bit became clear, became 0. And the last step is to toggle ith bit. Toggle ith bit means to swap. If it's 0, make it 1. If it's 1, make it 0. Then I have just need to do the XOR. XOR with 1 left shift I to toggle. Okay. In this case only for 7, let's say for first bit I want to toggle it from 1 to 0. And what will I do? I'll do XORing with 1 left shift 1. 1 left shift 1 will be what? I'll do XOR with 1 left shift 1 will be this. Okay. So I'll do XOR, it will be 1, 0, 1. Okay, same number XORing will be 0, and opposite number XORs will be 1. So it will be 1, 0, 1. So only first bit became swapped, became toggled. Clear? I hope you are clear with this. I'll put the notes also of this, okay, which I have made. We just need to learn this much to learn any of the bitmask related topic, in whether in prefix sum, whether in sliding window and all. Okay, so next we'll cover prefix sum with bit manipulations now. Stay tuned for that. Stay safe. Bye bye.